Okay, so as advertised, we're going to start off with representing real numbers with Taylor series. And then since that's pretty short, we're probably going to start the next thing, which is identifying a function given a power series. Now, this is a different form of what we did already. This one is a little harder. So let's use the Taylor series for the inverse tangent of x centered at a equals 0 to determine a series representation of pi over 4. So the Maclaurin series for arctangent is x minus x cubed over 3 plus x to the 5th over 5 minus dot 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 plus negative 1 to the n, x to the 2n plus 1 over 2n plus 1, and we keep going. And that's the summation, and going from 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1. And that has an interval of convergence of negative 1 to 1. Okay, so now we know that the arctangent of 1 is pi over 4. And so what we can do is we can plug in 1 for x in our expression for the Taylor series. So we get the summation in going from 0 to infinity, negative 1 to the n, 1 to the 2n plus 1 divided by 2n plus 1, or in other words, pi over 4 is equal to the summation n from 0 to infinity of negative 1 to the n times 1 over 2n plus 1. And that's the end of the example. So, as usual, if you have any questions, write them down, yada, yada. All right, now let's do a fun problem where we're going to identify a function given a power series. And so obviously the idea is we're supposed to be able to look at this power series and figure out what it is. All right, so one thing that we can do, and this makes this problem a relatively easy example, is we notice that we can combine, yes we can, these guys and write them as one power. And so that's the first thing we're going to do. Now, these are partly an art form and partly just recognition of stuff. So we're going to have 2x to the 2n plus 1 over 2n plus 1 factorial. And right here, you're supposed to recognize that this is equal to sine of 2 times x. So you're supposed to recognize that this is precisely the Taylor series of the sine of 2x. All right, let's do a slightly different one. And this is a wee bit of a more entertaining problem, right? Because we have 2x to the 2n over n minus 1 factorial, which looks absolutely nothing like anything we have. But we know that we have something with a powers over factorial. Specifically, we know that e to the x is the summation n going from 0 to infinity of x to the n over n factorial. And we have this x squared, x to the 2n, which if you think about this, you can think about this as, well, I could just take the 2 out if I wanted. But I'm not, I don't. Oh, let's just leave it there. We don't care. Think of this as x squared to the n over n minus 1 factorial. And so we might think, oh, wait, maybe an e to the x squared would be a good idea to look at. And when we do that, we get an x to the 2n over n factorial. Now, that might not look like we've gotten anywhere, but now we're looking and we see that we have an n minus 1 factorial in the denominator, which to me says maybe we differentiated. And so the next thing we might think of is that taking the derivative of both sides. So we're going to differentiate both sides. And so that's going to give me, right, when we differentiate, we move the derivative inside. All right, so maybe you're not super happy with this, and that's okay. If you're not super happy with this, what you can instead do is the following. And I can understand it's kind of hard to remember, how do I do stuff with my indices and what do I do with them? So let's think about this. Let me just move that back outside. And what I'm going to do is I'm just going to write down what my series looks like. So when n is 0, I get 1. I get 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, etc. Okay, well, the derivative of e to the x squared is 2x e to the x squared using the chain rule. And the derivative on the right, I'm going to get 2x plus 4x cubed over 2 factorial plus 3x to the 5th over 3 factorial plus something like that, right? Okay, now what? Did I get that right? Yeah, so far that looks right. Okay. Now, what I'm going to do next is a little bit of algebra, right? Because you'll notice that I have odd powers here, but even powers in my series. But let's see what happens if I just divide through by x. So what am I going to get? I'm going to get 2 e to the x squared is 2 plus 4x cubed over, I don't know where that became a 3 from, over 2 factorial plus 6x to the 4th, that's 2x squared, over 3 factorial plus yada, yada, yada. Okay, next thing we can notice is that we can factor a 2 out on the right-hand side. I apparently can't factor. 3x to the 4th over 3 factorial plus ... Okay, what else do we see? Well, we can simplify a little bit. Notice that 2 over 2 factorial is going to be 1. 3 over 3 factorial is 3 over 3 times 2, which is 1/2. 4 over 4 factorial is going to be 1/4, etc. And so what we see is that we have 2 e to the x squared equal to 2 times 1 plus x squared plus 1/2 x to the 4th plus, and if I kept going, I would have, can we just pretend that I wrote this correctly? 4 over 4 factorial would be 1 over 3 factorial, or 1/6, but we don't really care. And so we would get, the next one would be plus 1 over 3 factorial, x to the 6 plus ... And so we see that I have an n factorial in the denominator and an x to the 2n. So I have 2 times the summation, n going from 0 to infinity, of x to the 2n over n factorial. Just scooch the little 2 in, and I get 2x to the 2n over n factorial. So in other words, I just showed that 2x to the 2n over n factorial is 2e to the x squared. And that's an excellent place to stop, and some more examples will be coming in the next wonderful